students of Geography Department, Dr. B.R. Ambedkar Open University, and eminent resource persons and viewers, a very good afternoon to all. Today I welcome you all for this teleconference on the topic Geographical Phenomena, Earthquakes, Volcanoes, Tsunamis as well as the Cyclones. Today we have in our studios two eminent resource persons, Dr. Ravi Shankar sir and Dr. Ramachandra Prasad sir. Namaste sir, welcome you both of you. Dr. Ravi Shankar sir has completed MSc PhD from Osmania University, Hyderabad, and he was heading the Land Use and Land Cover Monitoring Division in Department of Space, Government of India, Indian Space Research Organization, National Remote Sensing Center, Hyderabad till 2019, and area of specializations are many. For few I am mentioning here: land and water resource management, land transformation, environmental impact assessment. He has vast experience of 34 years of experience, professional experience as an accomplished scientist, project coordinator and trainer with focused energy in the various domains, and he has coordinated and primary contributions for 18 national missions for use by the apex body, erstwhile Planning Commission, various ministries like Ministry of Rural Development, Ministry of Agriculture, Ministry of Water Resources and Ministry of Environment and all. And sir has published n number of research articles in various national and international journals. Sir has honored with two ISRO Team Excellence Award twice in the year 2014 and 2018. So another resource person, Dr. R. Ramachandra Prasad sir. Namaste sir. Sir is an associate professor in the lab for spatial informatics at IIIT Hyderabad, where his specializations in remote sensing, GIS and environmental science applications with a PhD in environmental science. Sir teaches a diverse portfolio of courses at IIIT Hyderabad, including remote sensing, ecological modeling, Geoinformatics and environmental sciences. Throughout his career, sir has led impactful research projects funded by the major organizations including DST India and the University Grants Commission. Sir has published 65 research articles in national and international journals and contributed a number of book chapters. He is also a member of multiple academic councils and advisory boards. With this brief introduction, I would like to welcome you all for this teleconference once again on the topic Geographical Phenomena, Earthquakes, Volcanoes, Tsunamis as well as the Cyclones. So in day-to-day life, whenever we read the newspaper, some or other part of the world is facing some sort of hazard which may lead to disaster, may not lead to disaster. Then the question arises that what is the hazard and what is the disaster? So most of us will be confusing between hazard and disaster. So before going into the topic, let me brief about the topic. So what is hazard? So hazard is a combination of both the words, like hazard like French word as well as the from the Arabic word. So I can define hazard in this way, that hazard is a dangerous condition or the event which have the potential for causing injury, which has the potential for causing injury to life or the damage or the property. So here I am saying that it has a potential, so that hazard might be natural or the man-made. Again, the natural hazard can be classified into four types, that is geophysical hazard, which is a earthquake, volcano, tsunami will come under the geophysical hazard, and the climatological hazard and the hydrological hazard and the meteorological hazard like cyclone. So here in this teleconference we are emphasizing on the two types of natural hazards like geophysical hazard as well as the meteorological hazard. Then what is a disaster? As I said you in the definition, that hazard may lead to the disaster. Whenever the human component is included in the hazard, it might become the disaster. So we can take the examples of the 2004 tsunami. So 2000 actually tsunami will come under the geophysical hazard, but after inclusion of the human component, it has transformed into the disaster. So here disaster can be defined as, it is coined by the two terms like the dis and aster. Dis means a bad and aster means a star. So that is bad star or insignificant or unfavorable condition. In unfavorable condition to whom, as the human component is included in this, that insignificant condition for the human being. So what way it is insignificant condition for or insignificant situation for the human being is that disaster can be defined is that it is the consequence of an event. That event might be natural or the anthropogenic. So it is a consequence of an event which causes the significant loss to the human beings or the property or the environment. That means in the hazard it has the potential to cause the loss, but in the disaster what we are saying, it will have or it is a consequence or it has the significant loss to the human being. So by this I think you may be aware the differentiation, or you can easily distinguish between the what is hazard and what is disaster. So let us know some more insightful inputs from the eminent resource person. So sir, as I have discussed that the earthquake, which is a part of geophysical hazard. So what exactly is earthquake and what causes an earthquakes? Could you tell me, sir, Ravi Shankar sir?
Yeah, earthquakes, if we try to understand per se from the word, it has so many components that precedes to understand from that particular terminology. Like we need to understand primarily the basic internal structure of the earth. Then on the earth, above the on the surface, we have so many plates that are there covering the crust, which are rather very I can say loosely placed things. So what do we call them as plates, and then we need to understand the plate tectonics, the theory of plate tectonics. So but now our focus is straight away we are focusing on earthquakes. So we try to understand what earthquakes are exactly. So if we try to define what earthquake is, that it is nothing but the shaking of the ground. Wherever we are there, what we are feeling on that, it is a sudden movement. It's a spontaneous movement that we experience that for a few seconds normally. And this movement is caused because of the sudden movement of the rocks that are there deep inside the earth. Because these rocks which are there deep inside, when they are subjected to high temperature and pressures, they store the energy in them. So this energy, this stored energy in the rocks, when it is released abruptly by the rocks, the crust releases that energy. So that we feel on the surface of the ground as earthquakes. And if we look into these components of these earthquakes, these are primarily caused because of the tectonic plate movements, which I have already just briefly mentioned only the terminology. Okay, we need to understand very in depth about that. So the tectonic plate movements are one of the reason for that, because the plates under the earth, they collide. Sometimes they move along with that, what we call as the fault movements or the fractures that are there, and then ultimately which are leading to the formation of the seismic waves or the earthquake waves which come onto the surface that we feel. The second activity that is responsible for that is the lava movement that causes vibrations, because the lava which is there coming out from the magmatic chamber through the conduit, what we call as the right terminology. So when it comes out because of the volcanic activity, it also creates a lot of vibrations on the crust that we experience when we are there on the ground. And then coupled with these two activities, the anthropogenic factors like sometimes mining, deep mining, and then during the process of this deep mining, a lot of explosions also will be taking place, and drilling deep into the ground can also trigger small earthquakes.
Thank you so much, sir. As you said that entire earth is covered with the major and minor plates. So what exactly tectonic plates and what exactly this seismic waves, sir?
So before we just touch upon that, we try to understand what are the parts of the earthquake.
Okay.
Okay. The one is the direct, what we call as the seismic waves or the earthquake waves. Okay. And then they will be originated from a place from the internal part of the earth. So that is what we call as the focus. Okay. That is the place where the earthquake originates, and then where it is felt on the ground. So that is called as the epicenter. So when we are trying to look into it, epicenter is nothing but the point on the earth's surface where directly the impact of the earthquake is felt. So if we try to understand, there are one more phenomena that is attached to it, that is what we call them as aftershocks.
Okay.
So an earthquake, once it happens, it will not stop just like that. Even aftershocks are also we feel. So for example, during the Gujarat earthquake, once that happened, so everything was recorded. Okay, the people they started doing the what they call as disaster assessment. Okay, impact assessment. So when during that process, even they could feel the tremors that are there, even after the main shock that was there. So coming to the strength of the earthquakes, how they are measured. Before going into the plates part, we need to understand what is the strength of the earthquakes. It is primarily measured in terms of what we call them as the Richter scale or moment magnitude scale. Okay, these earthquakes, they are around 2 to 3 on scale. They are the smaller earthquake that will happen on the ground. But big earthquakes, they will cross 6 on the Richter scale, which are high 6 or higher, which will cause the major damages. Okay, so some of these earthquakes, they are also create landforms at the end of the activity. So they are nothing but one example is the Rift Valley in the East Africa, and the Graben and Host, and also the tsunami terraces.
Okay,
so
sir.
They also sometimes create mountains. The best examples are the thrust mountains that are created as a result of the collision of the during the process.
Okay. So thank you. As you have said, discussed about the focus and the epicenter.
Yeah.
The starting point is focus, and the impacting area on the surface is epicenter. So exactly where do most earthquakes will take place, sir?
Yeah. Coming to the previous question, what you have asked about the tectonic plates. Now, because of the nature of the topic, I need to explain about the brief nature of that. But tectonic plates, these are the plates that are floating on the molten rock material that is there in the internal part of the earth. They always keep moving. So during that process, very, very slow movement, because that plate movements one cannot feel. But now there are technologies that are available that based on which we can see how many centimeters based on which it is moving. It is moving only in terms of centimeters. Okay, and sometimes what they do is that they push and then they pull down, and then when they slide against each other, so they cause earthquakes along the fault lines.
Okay, sir. So I mean the earthquakes will occur at the fault lines, right? Am I right? So can earthquakes happen underwater, sir?
Yes, earthquakes can definitely happen underwater, because what is happening is that they are all called as submarine earthquakes.
Okay.
And they are the ones which are responsible for causing the tsunamis, because it is totally under which are under the ocean all these things, the phenomenon that is happening. As a result, what is happening is that the large volume of water, whatever that is there, it is moving in a wave form with high pressures, flooding the coastal areas. So in the form of what we call as the giant sea waves, and they flood the entire coastal areas, resulting in the damage.
Sir, as sir has said that earthquakes can take place under the water. So does the groundwater depletion triggers earthquakes, sir? This is my question to Ramachandra Prasad, sir.
Yeah. So recently there is a study which is actually focusing on what is the impact of serious groundwater depletion in the current scenario of climate change, where there is a low rainfall and there is a excessive extraction of the groundwater that actually creates a kind of stress within the earth surface. So mostly the tectonic plates what we are mentioning, actually because of this extraction of the groundwater act as a lubricant. So this lubricant actually makes them to slide in a normal stabilized way. But once that actually water is extracted, they're more prone to this kind of destabilization that is actually resulting in the earthquakes. So recently the earthquake that happened in Morocco in 2023, the study estimated that because of the excessive groundwater extraction for the agriculture purpose in conjunction with the low rainfall and totally the dry conditions are primarily responsible for the triggering of this kind of earthquakes. So mostly in future, because of this kind of drastic dry conditions with the low rainfall, there is a possibility that more earthquakes may occur.
Okay, thank you so much, sir. Sir, my question to Ravi Shankar, sir. Sir, can we predict the earthquake? If earthquake happens, how can we stay safe during the earthquake?
As of now, I can say my answer is no. They cannot be predicted.
Okay.
But, however, this precise prediction cannot be there. But what they do is that the scientists they have analyzed and they are still analyzing, because I can say that approximately over 150,000 tremors in a year are being recorded by the scientists all over the world. So these monitoring stations, they pick up the data, analyze the data, and now we are having various artificial intelligence tools that are also there. They are putting all these efforts to understand the patterns of the earthquakes, and also the studying the faults and the fault lines that are, and also the movement of the plates, and then they are trying to estimate the risk and prepare primarily that too for immediate purposes, for giving an early warning system.
Okay.
So that is the current state of affairs.
Sir, as Ramachandra Prasad, sir, as you said that due to dry condition, it may it may get more number of earthquakes. So how might climate change influence the occurrence of more number of earthquakes, sir?
Okay, so this question is I'll address, but it may be actually contradicting with the previous one also.
Okay.
So recent studies indicate that high intensity rainfalls are also one of the cause for the creating some kind of stress within the earth crust. So the rainfall which actually forms accumulated on the surface of the earth, it creates a kind of a weight that actually imposes some stress on these plates. That actually leads to the movement of these plates, which can be felt as a earthquake, but they are not really that much significant. So one, we have to remember that the primary cause for the earthquakes is the tectonic plate movement, that is for sure. But now in the current scenario, these are some of the additional factors what we are trying to see. Either it can be anthropogenic, as I mentioned about the groundwater thing, or it can be the naturally the change in the climate that is happening because of the human interferences. So mostly the rainfall intensity. Also, when the rainfall, actually the water seeps into the rocks, actually it penetrates into the pores, and these pores actually they expand, and pores in between the two rocks, the friction that holds between the two rocks is actually lost, that actually rolls over, and that when it's very close to the any fissured fault, that actually triggers the earthquakes. And one more is actually because of the high intensity rainfall, we can see rolling or erosion of the material. So this erosion of the material is nothing but movement of mass from one part to another part, that is actually creating some kind of imbalance that actually also destabilizes, and they also result in the earthquakes. But these are some kind of the studies that are still going on, the research, that how far these rainfalls are really good in triggering the earthquakes.
Okay, thank you, sir. So, in my question to Ravi Shankar sir. So, recently we have come across the news like Joshimath sinking. So, can you brief up about the Joshimath sinking?
Yeah. Joshimath, if you just look into that location, it is located in the Himalayan region, especially the northern part of Uttarakhand. Okay, it is of late it is very frequently coming into news because of the subsidence due to instability that is happening in the area, and people, the scientists also observed a lot of cracks in the buildings, and also there were forced evacuations that are happening there. If we look into the seismological map of India, this particular area falls under the zone 5, which is a high intensity zone. So what has happened here is that the reasons, primarily reasons, if we look into that, is geological vulnerability of that area, and much of the town is constructed on the debris of the landslides. And if you look into the second factor, you know that these particular areas, they are very old because it is having a lot of importance from various reasons. So there was a lot of unplanned construction and rapid urbanization that is happening in that area. And then the third factor is the lot of hydrological projects that also have coming up, hydroelectric projects that are coming up in that area, and then lot of tunnels have been constructed, and as a result there is also a water seepage that is happening in that, and then road construction to make movement in that area, and then deforestation and soil leading to soil instability. And because of the seismic activity and also the climate change, heavy rainfall and landslides were some of the reasons that can be attributed to the sinking of Joshimath.
Thank you, sir. So, as thank you so much for briefing about the earthquake. So, let us discuss about the volcano. As we know that every volcano eruption is followed by an earthquake, and most of the severe earthquakes cause the volcanic eruption. So, what causes volcanic to erupt, and what are the types of volcanoes, sir? Can you brief this, Ravi Shankar, sir?
Yeah. A volcano, it erupts when pressure builds up inside the earth. So what is happening is that the magma that is there located in the magmatic chamber in the internal part of the earth, it rises up because of the heavy pressures that are created there. It comes out through the cracks in the crust. Then when it reaches the surface, it explodes, and then resulting in the flow of lava, ash, and also gases. So magma is nothing but the molten rock material which is located in the crust itself. Once it comes out of the earth and then start flowing, then it is called as the lava.
Okay, thank you, sir. So, Ramachandra Prasad, sir, can you provide insights into the catastrophic eruption of the Toba volcano?
Okay. So, when we talk about the volcanoes actually has a long history of one of the major disaster that actually lead to different hazards. So, if you look into this Toba volcano, which is actually popularly we call it as a Toba catastrophic theory. So it is one of the largest volcano that happened, which created large of damage to the property as well as to the human beings. So the Toba actually volcano, which is erupted almost around 75,000 years ago, currently at the Toba lake, which is in the Indonesia, in the Sumatra island. So this volcano, when it erupted, it actually released a huge amount of ash that actually formed about 15 centimeters thick entire Southeast Asia, also in the South China. The ash that actually reached the upper part of the stratosphere, it covered the layer, and that actually results in a phenomenon called global dimming. The global dimming is a process where there is no or very minor penetration of the sunlight into the earth atmosphere. So as the sunlight is not reaching the earth's surface, this actually resulted in almost low climatic conditions. The studies refer that almost there is a drop of 3 to 5 degrees of temperature, and there is almost 5 to 6 years winter period, and it is continued for almost 1000 years. So usually we refer this kind of winter conditions as volcanic winters. So mostly, in addition to the population, actually they call that a theory that is, it created the population bottleneck, in a sense that it has a serious impact on the population of India and East Africa. So when you say what is population bottleneck, it is actually a decline in the population because of any sudden drastic event, something like this volcano. So this actually resulted in almost 40 breeding pairs, that is almost the genetic erosion happened, and that is given as a condition where total humanity is lost.
Okay, thank you, sir. Sir Ravi Shankar sir, as you have explained that there are different types of volcanoes over here, like dormant volcano, extinct volcano, and active volcano. Does India is having the active volcanoes?
Yeah, there is one which is there in Andaman Islands. That is a barren island.
Yes.
Okay, this has a long history, I can say, wherein it is the only active volcano of India. Second thing is that basically it is a stratovolcano with a 2-kilometer wide caldera. That is the opening of that volcano there. And it recorded its primary eruption. I think the earliest record that was there was dates back to 1787, and the most recent one is being 2018 to 2022. In between there were a lot of eruptions there, and it also supports some wildlife because of its dormant active only for some periods, and also a lot of marine biodiversity is also there around it, and it is accessible only via boat. Okay. Nobody can reach, because it is basically the name itself connotes that it's an island.
Okay.
Okay.
Yeah.
And with restricted landing permissions in that area.
Okay, thank you, sir. Sir, as we have discussed here, natural hazards may transform into the disaster, and they will impact on the environment and all. So, do volcanoes help environment? If you look at the other side of the volcanoes, do volcanoes help environment, sir?
It is to me.
Yes, sir. Ravi, sir.
Yeah, volcanoes definitely help. Primarily, if you look into the composition of the volcano, it has the rocks that are coming out from that, then the gases, and also some of the liquid. So basically, these volcanoes, they help in once they land on the Earth's surface, they enable to create fertile soil. They will make the soil fertile, and also they are the sources of rich minerals, and also they help in formation of new islands like the Hawaii which is basically a volcanic island.
Okay, thank you so much, sir. As we have discussed both the aspects of the positive and negative aspects of the natural disaster, natural hazard, they may turn into the disaster. We can't say that. So now it is a third. So there is a small announcement I forgot. So the viewers, I request after 15 minutes you can call. If you have any doubt, you can call to this number. Please note this number 040-2368-0456. I am repeating this number 040-2368-0456. Thank you. So now third geophysical hazard, let us discuss about the tsunami. As I discussed in the starting of our teleconference. So actually tsunami will come under the natural hazard, but it may turn or it may transform into the disaster after inclusion of the human component. So can you tell me, sir, what is the tsunami and how it is generated? It's a question to Ramachandra Prasad, sir.
So tsunami, the name itself indicates, it is actually a Japanese word, where actually su refers to harbor and nami refers to wave. So in a simple sense, it is something like a harbor wave. Most of the times people also by mistake refer this as a tidal waves, because these tsunami waves have the same rise and fall, something to a normal tidal wave, but there is a variation between the tidal wave and the tsunami wave, because tsunami wave, when it reaches to the coast, it has enormous energy. So tsunamis typically, as we discussed about the undersea earthquakes, it is one of the prime factor that triggers the tsunami. So when there is this kind of slight tectonic movements under the sea, that actually when one tectonic movement undergoes beneath another, that actually flashes the water, and this water erupts and finally it starts resulting in the form of waves, what we call as a tsunami waves. So the waves actually has a height of 5 meters and mostly they reach to the coast. So normally the wave height actually it is 5 meters or 50 to 70 feet height, and between 40 minutes to 1 hour there may be two major waves. So one major wave has some 10 sub waves, and these waves actually they move to the coast with a very high speed, around 700 to 800 kilometers per hour. But these waves, when once they reach the coast or they hit the coast, the speed of these waves decreases. But with speed decreases, it does not mean that they are not that much having hazard thing, but they actually carry lot of energy that actually brings the disaster. So these waves actually they almost penetrate into 500 meters in the inland. They actually destroy all the infrastructure or the population, ecosystem, anything on its way. The retreating waves are also has a serious impact, carrying all these kind of structures. So mostly not only the underneath earthquakes are primarily responsible for the tsunami, but there are some other factors like undersea landslides or undersea volcanic eruptions, and very rarely if there is something like a large impact of the asteroids and the meteorites, that also results in the tsunami. It is something like a large object when falls in the water and the water splashes, something similar may happen with the hit of the asteroids.
Sir, as we know that whenever the disaster or the natural hazards will take place, most of the countries will be affected due to that. So including our India in 2004 when the tsunami was faced, when the tsunami was there, so most of the countries have been impacted, including our India. But in whenever we come across, Japan is a country where it will hit many of the natural hazards at the tsunami. What is the reason behind that?
So if you trace back the history of tsunami, it was started around 1480 BC. The first tsunami that occurred in Mediterranean Sea, where actually Minoan civilization is totally wiped out. Then we have different records in the history happening these kind of tsunamis in the Alaska, Lisbon, Chile, Japan, Philippines, and we also have the record in India also. But then if you look into the Japan is a country which was hit by almost 65 tsunami disasters, that actually 2011 was the last tsunami that happened in the Japan. So now why it is actually more prone to this kind of tsunamis? So if you look at the Japan, the geographical location, it is actually sitting along the ring of Pacific heights, where actually we see very high seismic activity of the tectonic plates that actually results in this kind of tsunamis, earthquakes as well as the volcanic eruptions. So mostly Japan is at the confluence of 4 tectonic plates, that is the Pacific, Eurasian, the Philippine Sea and the North American plate. So these plates are actually under the constant movement that actually brings that kind of vibrations that actually results in the tsunamis. So mostly one plate actually undergoes the subduction, usually called as the beneath, we call this as a subduction zone. The subduction zone actually is primarily responsible for this kind of tsunami. Since Japan is very close to this kind of subduction zone, we see that it is more prone to this kind of tsunami events.
Okay, thank you sir for giving a brief explanation of this. Now my question to Ravi Shankar sir. Sir, as a tsunami has taken place in year 2004, so what is the impact of 2004 tsunami on our Indian peninsula, sir?
In the year 2004, as it is rightly pointed out, a major tsunami has occurred. It has triggered with a Richter scale of 9.1 to 9.3, because the Richter scale I have already just mentioned in the earlier session here on earthquakes. That much of magnitude of earthquake off the coast of Sumatra it has happened. So in Indonesia. So it has caused widespread devastation across all the coastal regions there, especially the Andaman Islands and Nicobar Islands, more so the Nicobar Islands, and also the eastern coast, southeastern coast, that is mostly the Tamil Nadu. So where the impact was seen very clearly. When you look at the epicenter of this particular earthquake that has happened, it was just 160 kilometers away from the Nicobar Islands. So making them one of the worst hit areas of the total episode. So as you know that the total number of islands, including the rock formations, there are about 572 islands that are there in the Andaman and Nicobar group of islands, and of which many of them, they were either damaged, submerged, or even the flora and fauna also got impacted very drastically, severely damaged, especially the Nicobar group of islands. There was you can see some of the islands, they were cut into 2 parts, I can say, with the water that is there in that, resulting in submergence of some of the island, that is part of the island that is there in the middle of it. So this is a very this has caused a maximum destruction in that area, and experiencing structural and infrastructural damages in the to the Andaman coast. But however, when you look into the damages that occurred in the Indian subcontinent, so there it was mostly restricted to the Tamil Nadu portion, where it has severely affected the Madras, that is Chennai, then Kanyakumari, then more in Kadalur and Nagapattinam. Kadalur and Nagapattinam had a serious damages across those areas. So if we look into this, based on the lessons learned that was there, means immediately after that, in the year 2007, the Indian Tsunami Warning Center was established.
Okay, so thank you so much, sir. As we know that the disaster may cause significant loss not only for the human being but also ecosystem and the environment. Sir, my question to Ramachandra Prasad sir. Sir, as disaster will cause a significant loss to environment and ecosystem, as your PhD thesis is on Andaman and Nicobar Island, could you explain, sir, what is the impact of tsunami 2004 on ecosystem of the Andaman and Nicobar Island?
Yeah, so partly actually it is covered by Dr. Ravi Shankar. As you mentioned, if you look into this kind of impact of tsunami on Andaman Nicobar, so Nicobar Islands are more sparsely affected with the Andaman. And if you see with reference to Andaman, actually there is a geological impact happened, where we see that there is a upliftment of the land on one land side and there is a subsidence. So this actually we found in the Little Andaman, where actually when there is an upliftment, the coral reefs which are in the water, they got exposed. Coral reefs are already threatened by the climate change, and in addition to this, the disaster like tsunami totally degraded those corals. And on the other side, where there is a subsidence, the vegetation, mostly the coastal vegetation, it's a combination of littoral and the mangroves, they are actually submerged. So when you look into the entire Andaman stretch, so we found that along the coast, mostly mangroves and littoral forest are affected. In addition, these tsunami waves are also penetrated into the agriculture fields, making most of the soils, saline condition not suitable for the agriculture, with the impact on the human livelihood. And if you see in respect to Baratang actually, when there is a tsunami impact, there is also mud volcanoes. So mud volcanoes are found only in the Baratang Islands, and there is an eruption of these mud volcanoes what we see in the Baratang Islands. But the Havelock and the other islands, they are not much affected, and they are best chosen as a tourist site. Then if you come to the Nicobar are totally damaged because of the tsunami. The prime reason is because they are very close to the epicenter, that is the Sumatra Island. And if you see the Great Nicobar, the lower tip part, what we call as a Galatea Bay, which actually contains a good area of mangroves, the totally mangroves are degraded. And if you look into the Kachal is an island near to the Nicobar, it is totally degraded. That now in the current studies what we did also, till now there is no recovery of the mangroves. The mangroves that are totally hit by the tsunami, totally mangroves are lost, and actually we see that there is a subduction that actually causing the movement of water into the forest system. So maybe in future with the increasing sea levels, there is totally the island may be submerged. And what sir mentioned that about one island is totally split into two, it is actually the Trinket Island, where actually people initially thought that it is broken into three parts, but actually it is the substance of the island that actually created such kind of impact. So mostly mangroves and the coral reefs are affected because of this tsunami impact.
Thank you, sir. So after this tsunami, actually our Indian government has established one center, that is INCOIS in our Hyderabad. So can you tell me what is the role of this INCOIS and how does it works actually?
Yes, so based upon the impact of 2004 tsunami, then Indian government in collaboration with International Disaster Management, they try to come up with a early warning system, what they call as an Indian Tsunami Early Warning System, IIIT. This is done with the responsibility hand over to INCOIS, Indian National Center for Ocean Information System. So the prime purpose of this center is, this IIIT is that they have a setup of sensors which are placed in the sea. So these sensors, they capture the whatever the things, tremors that is happening in the sea levels, then these actually signals are transmitted to the sensors to the communication thing. So they decided something a pre-threshold. So if these tremors are below this, it is not that much serious. But if these tremors are above the threshold, then they'll send the tsunami warning to the people, indicating that there is a possibility that the chances of tsunami will be there.
So thank you so much, sir. Now we'll come to the meteorological hazard. Cyclone is among them. So what exactly cyclone and how do they generate, sir? Question for Ramachandra Prasad, sir.
So cyclone are actually the violent storms which are actually accompanied with the strong winds. And these storms actually they are moving around a calm center where actually we say low atmospheric pressure, and the wind actually moves with around 50 to 250 kilometers per hour, and these cyclones actually also carry the rainfall. That is actually the main impact by these cyclones. So if you look into how these cyclones are formed, there are the two factors. One is the temperature, another is the moisture. So if you look into the ocean systems where actually the water get heated up, so the moisture above the surface of the sea water, they also get warm up. This warm moisture, it moves towards the up. When it moves towards the up, at the near the surface there is a low air. So air from the other side, actually because it's a movement of high to the low, from the high pressure areas it is moving to the low pressure areas. So continuously we can see a cycle of air from the high side to entering into the lowest, and again it gets warm up and move towards the up. So this cycle continues. When the warm air moves up, actually it forms, actually condenses and forms the clouds. So over time of this cycle we see a massive formation of the cloud systems, which are accompanied by the strong winds which are actually rotating. So this rotating along this thing, clouds thing, actually forms a low pressure at the center, what typically we call as an eye. So eye, which has a low pressure, and surrounding is the high pressure areas. From high pressure areas the wind moves into low pressure areas, and we can see that churning of the wind, which actually typically we call as a cyclones. So these cyclones actually, for the formation, temperature is the important factor, what we call as the sea surface temperature. So it is optimally the temperature is around 26.5 degrees. So if the sea water has this much of temperature, there is a possibility of formation of this kind of cyclone systems.
Sir, when the cyclones are occurred, my question to Ravi Shankar sir, when the cyclones are occurred, they are named differently. So how the cyclones are named, sir? What are the basis for nomenclature of the cyclones?
See, this is a trickish question. I can say that in the year 2000, a group of nations under the aegis of World Meteorological Organization and United Nations Economic and Economic Commission and Asia Pacific, what we call as UNESCAP, which is headquartered in Bangkok, Thailand. With under its aegis, around 13 countries, they joined together to give the nomenclature for these cyclones. So what they have done is that they formed a panel on tropical cyclones and then finalized a list. So 13 countries, and each country was given a chance to give 13 names. So 13 into 13, so it is 169 names have been finalized. So these 169 names, they were released by the India Meteorological Department in the year 2020, and were provided by all these were provided by these 13 countries. So why it was done is that it is easy to make the people easier to understand and remember the names very easily. Second thing is that when it is also easy to identify the individual cyclone, like the way we name different people, which is having a unique identification like that. Okay, and it also creates awareness of its development and rapidly disseminate among the population, so that the warnings concerning that particular cyclone can be prompted, and then it will also eliminate the confusion and where there are multiple cyclones of similar things that are happening in the different countries, so that this nomenclature will enable them. But at the same time, there were certain restrictions that have been put on that. The proposed name should be, it should not contain any things that are related to politics or political figures, and religious beliefs should not be included in that. Cultures and gender and these things, all things should be avoided, and name should be chosen in such a way that it does not hurt the sentiments of any group of the population across the globe, and at the same time it should not be rude and cruel in its nature. when it is named, and it should be short, easy to pronounce, and should not be offensive to any of the member or the member countries or anyone in the world. So the maximum length that has been restricted is only 8 characters, that is 8 alphabets.
Okay, sir, thank you so much, because very interesting story behind the nomenclature of the cyclone. So it is very interesting. Thank you, sir. Sir, this question to Ramachandra Prasad, sir. Sir, as we observe in generally, the east coast of India experiencing most of the cyclones rather than comparing to the west coast of India. So what is the reason behind that?
Okay. So in fact, it is something like that. Why more cyclones happen in Bay of Bengal compared to that of the Arabian Sea?
Yes.
So typically, if you look into the case of these cyclones, mostly if this one cyclone happens in Arabian Sea, there are 4 cyclones that are happening in the Bay of Bengal. In a study conducted for referring cyclones between 1990 to 2020, it was found that around 73 cyclones happen in Arabian Sea, while there are 190 in the Bay of Bengal. So then, what is the primary reason that is actually triggering more cyclones in Bay of Bengal? We can make it as 3 reasons. One is actually the temperature. So temperature or the warm water, as I mentioned previously, that is mainly responsible for the cyclone formation. If you look into the Bay of Bengal is landlocked. So there is it does not have any cool water entering into that one. As a result, the temperatures of the Bay of Bengal water rises. So mostly they may be coming to 26 or 27, which is actually a good for the formation of the cyclones. So mostly if you see the cyclones, they happen between May to June and something in the mid-September to mid-December. And in the case of May, the temperatures in Bay of Bengal may shoot up to 29 to 30 degrees, and that is a good for the cyclone formation. While if you look into the Arabian Sea, there is a strong winds that actually creates the evaporation of the thing that actually maintains the low temperatures. So these low temperatures does not allow much formation of this kind of cyclone. That is one reason. And second reason is the moist air. So warm water and moist air are the 2 fuels for the cyclones. So moist air actually, if you look into the Arabian Sea actually receives strong winds from the dry countries like Oman and Yemen. So these dry strong winds actually absorbs the moisture, does not have any moisture content in the atmosphere, while that is not case with the Bay of Bengal. And third reason is typhoons which are actually coming from the Pacific travel into the Bay of Bengal. Typhoons are nothing but the cyclones, what we usually refer in the Pacific, Northwest Pacific region, mostly in the Japan and in the Philippines. So when these typhoons which are actually weak that are entering into the Bay of Bengal, and the Bay of Bengal has a very good comfortable conditions, are actually intensified these typhoons, and that actually results in the formation of the cyclones. So warm water, moist air and this kind of typhoons that actually trigger more cyclones in the Bay of Bengal.
Thank you, sir. Sir, how does the climate change influence the cyclones, sir?
Okay, so climate change, they estimated that Bay of Bengal has more cyclones compared to that of the Arabian Sea, but currently they are also referring that are in the chances of having cyclones in the Arabian Sea, the frequency is increasing. Mostly a study conducted indicates that about 9.4% of terrestrial ecosystem is subjected to transformations because of these cyclonic conditions. They also observed that the frequency of the storms that is happening, the interval from 19 years to it is reduced to 12 years, indicating that the frequency of occurring this kind of cyclones is more. So this is a study that is done based upon the storm model, which considers the current periods of 1980 to 2015 and prediction from 2017 to 2050. Based upon that, they identified that the ecosystem is going to transfer in future because of these cyclonic patterns. Another reason, which is something in hypothetical condition, they call it as a hypercane. Hypercane is a scenario, is a super cyclone that may happen in future when the sea temperatures exceeds 50 degrees centigrade. So these high temperatures are more favorable for the cyclones. So now what they refer that, what is the difference between the current cyclones and this hypercane? It is something hypothetical thing that may happen in the future if the temperatures are increasing. Obviously the sea surface temperatures are increasing because of the high absorption of the carbon dioxide, so maybe later in future this may happen. So the difference is that the current cyclones, they reach into the only the lower stratosphere part of the atmosphere, while the hypercane, it can also enter into the stratosphere region. So when this hypercane enters into stratosphere region, it totally destroys the ozone layer. The water molecules present in this cyclone thing also interacts with the ozone layer and resulting in the formation of the oxygen, depleting the ozone, and finally making the way for the ultraviolet rays. So this is a hypothetical scenario. People have guessed that this may happen in future because of the climate change.
Thank you so much, sir. So last but not least, one question I'm having from the earthquake, sir. So most of the earthquakes have been concentrated in and around the circum-Pacific belt. So can you tell me the reason behind that, sir? Shankar, sir, please.
Yeah, if you look at the location of these volcanoes or even the earthquakes, it is located in what is called as the zone of, or the region of ring of fires. So the frequent volcanic eruptions that are happening in that is one of the primary reason that is happening in this zone to have more number of earthquakes. And secondly, when you look into the what do you call the geology of that area, you have what do you call the Great Marina, so that that is also formed. They are even the higher than even some of the mountain ranges that are there even on the terrestrial surface. So these are contributing to the more what do you call phenomenon for earthquakes that are happening on the surface.
Okay. So thank you so much, sir. As we have covered geophysical hazards along with the meteorological hazard. In the geophysical hazard, we have covered earthquakes, volcanoes, as well as the tsunamis. And in the meteorological hazard, we have covered cyclones. I think our students of the geography department as well as the viewers have benefited from this teleconference. In spite of all, on behalf of all of them, I am very thankful to the two of the resource persons, Ravi Shankar sir as well as Dr. Ramachandra Prasad sir, for being here and explaining elucidately with the examples and all things, and they have given examples of India as well as the throughout the world. So I think definitely this teleconference has benefited our students as well as the viewer. Thank you once again. Thank you all.